So let's look at another set of the general business application of integral calculus. And the first example, it's the rate of change of sales of a company after an advertisement campaign is represented by f of t equal to 3000 exponent negative 0.3t, where t represents the number of months after the advertisement. The question is asking, we should find out the total cumulative sales after 4 months, the total cumulative sales after 4 months, and also the sales during the 5th month, the sales during the 5th month. Also, we should also find out the total sales due to the advertisement campaign, and it has been stated that we should take exponent negative 1.2 to be equal to 0.3012 and exponent negative 1.5 to be equal to 0.2231. But I know since you are using calculator, this shouldn't be a problem. If you get over to that point, you can just use your calculator to punch them out. So let's solve this question. So the function given, it's the rate of change of the sales. So when you say the rate of change of the sales, I know you did from your calculus 1, you don't have any problem with differentiation or the gradient function, right? The rate of change. When you say something is the rate of change, right? Yeah, you need to understand at a point. So based on that, the sales function, the rate of change of the sales function is given to us as f of t equal to 3000 exponent negative 0.3t. That is small f of t. This means that there was something called a capital F of t, and this capital F of t was differentiated. That is df of t with respect to the time, which is t, so that we were able to get f of t, which is the small t. Right? So this capital T, capital F was differentiated to get a small f of t. And that small f of t represents our rate of change. Right? When you say the rate of change, always keep in mind rate of change and they represent by f of t. Remember, don't forget that this is a rate of change, right? So it's equal to this. So based on that, we can say that if we want our capital F back, then, or the original sale function, then we need to integrate so that we can get the original sales function. And therefore, when we integrate this, we are going to get what? F of t. So getting that f of t, we are going to get f of t equal to, right? So when we are integrating this side, we also have to integrate this side as well. So it's going to be equal to the integral of 0 to 4, because we are, or let's do it general before we come to the 0 to 4. So it's going to be the integral of 0 to t of the small f of t dt. So now, that is what if we assume that f of t, this capital F of t, is the total sales after t months. So the sales rate is the f of t, as I've written it here, and it's equal to that small f of t. And therefore, we are getting this one when we integrate the left-hand side and the right-hand side is the function itself. So let's do a bit of substitution and then look at what we can arrive on. So in doing a bit of substitution, or in solving it further, we are going to say that the total cumulative sales after 4 months is also, or can also be given as f of 4 equal to integral of from 0 to 4, as I wrote earlier, and then f of t dt. So in doing further simplification, we are going to get integral of 0 to 4 and then 3000 exponents negative 0.3t or dt. And therefore, doing our integration, we are going to get 3000 exponent negative 0.3t over negative 0.3, and don't forget that we have a limit of 0 to 4 months. 0 to 4 months. And therefore, we are going to get negative 10,000 exponent negative 1.2 minus exponent 0. And I hope you are aware that exponent 0 is 1. And therefore, we are going to get negative 10,000 exponent negative 1.2 minus 1. And in all, we are going to get 6,988 units. That is for the first 4 months. That will be our total cumulative sales after the first 4 months. So let's move ahead and solve the others as well. The next question, what is it asking us? So the next question is asking us that we should find the sales during the 5th month, and the sales during the 5th month is between the 4th month and then the 5th month. So your limits, nothing is going to change for the first one. So basically the limit is the one which is going to change, and the limit is going to change from 0 to 4, and then it will come to from 4 to 5, because we want the sales during the 5th month, and the 5th month will be between 4 and 5. So the lower limit is going to be 4, and then the upper limit is going to be 5. And the same function will be used, which is 3000 exponents negative 0.3t all multiplied by dt. So in doing simplification, we use the same approach as we solved the first part. And therefore, we are going to get 3000, the same integration 0.3t over 0.3 is negative. So the lower limit is 4, upper limit is 5. And in that case, we are going to get negative 10,000 exponents negative 1.5 minus exponents negative 1.2. And at the end of the day, you are going to get negative 10,000 multiplied by, if you look at the question, you were given that exponents negative 1.5, you should take it as 0.2231, and then exponents negative 1.2, you should take it as 0.301. So in this case, we are going to do some simple substitution over here, which is 0.2231 minus 0.3012. So doing our simplification or using calculator to punch this one, you are going to get 781 units. So let's be quick and solve the last parts, I believe. is not something difficult here, and it will take you just few minutes or few seconds to finish up the last part. And the last part is telling us that we should also find out the total sales due to the advertisement campaign, right? The total sales due to the advertisement campaign. So let's look at something here. The total sales due to the advertisement campaign is going to be like from 0 to infinity, right? The t, right? We are going to differentiate, integrate it. That is from 0 to infinity due to the advertisement campaign. So basically, we don't know the time that the advertisement, they stop the advertisement. So that's why we are integrating it from 0 to infinity, right? Let's assume that they did the advertisements throughout without stopping. So in that case, we are going to get something like integral from 0 to infinity, which is 3000 exponent negative 0.3t dt. And doing your integration, you are going to get 3000 over negative 0.3, then exponent negative 0.3t, and then our limit is going from 0 to infinity. And at the end of the day, we are going to get negative 10,000 and then 0 minus 1. We assume that when you put an infinity there, as x approaches infinity, since this is negative, the value exponent here will be approaching 0. And therefore, when you put the 0 up there, we are going to get 1. Exponent 0 will be 1. So at the end of the day, we are going to get 10,000 units. So this is the total sales due to the advertisement campaign. Thank you for watching, and see you in my next video.